Use a compass a few feet away from the dish to find the azimuth direction. Loosen the mount bolt so that it can freely rotate to an approximate azimuth location. Now fully tighten all 8 of the mount bolts that secure it to the mast. Make sure the mount nuts are secured against the mount to keep the bolts from becoming loose over time. An inclinometer is a handy tool used to show the elevation angle of the satellite. On this 1.8 meter dish, the inclinometer is positioned on the bottom of the mounting arm as shown. Why the inclinometer is used for a reading at that specific location is because it avoids having to calculate in an elevation offset angle. To understand this, it can be visualized by the angle of the satellite transmission and the angle of the radio transmission. The difference between these two angles is the elevation offset angle. On this dish, the lower bracket is perpendicular to the satellite angle, so when the inclinometer is placed there, the actual elevation angle is shown without the need to add the offset angle. The elevation of the dish is adjusted skyward to roughly 48.7 degrees. You may wish to use the inclinometer to set the dish elevation slightly lower or higher in the sky than you expect the satellite to be. Next, we need to orient the radio to specifications. In this position, the radio is set for horizontal receive, vertical transmit, and in this position, it is set for vertical receive, horizontal transmit. The customer sheet shows vertical receive, horizontal transmit. The SuperBuddy also showed a polar offset of plus 3.2 degrees. To adjust the polar offset, position the inclinometer on the side of the transmitter and turn it clockwise 3.2 degrees from 0 for a positive polar offset. You would rotate the transmitter counterclockwise from 0 if the polar offset was a negative number. Now, with all 3 axes approximately set, the SuperBuddy can be used to find the satellite signal. You can use a short 10-foot length of RG6 coax cable to connect the SuperBuddy to the LNB receiver of the satellite radio. Turn on the SuperBuddy and scroll to the satellite to be connected to, which was Galaxy 18. Also, make sure to set the SuperBuddy to vertical receive, which was done earlier. Position it to rest on the mount so that you can view the display. The slow beeping will increase in speed as well as display the signal strength, or locked, when the satellite is found. Background signal strength is measured on the left bar, which can see all satellites. The right bar will show the actual signal strength of the connecting satellite. Slowly sweep the sky by moving the dish azimuth by hand. If you do not find the satellite on the first sweep, lower or raise the dish 1 degree closer to where you believe the satellite is located. Sweeping patterns of 1 degree increments assure that you will eventually find the satellite. This process takes time and patience. Move the dish slow enough so that the SuperBuddy has time to process that the signal has been found. Both the display and quick beeping will alert when the signal is found. However, the pointing process is really just beginning. To turn off the beeping, press the speaker button. Now confirm the skew angle is as precise as possible. Also move the azimuth fine adjust nuts so that they are lightly secured on both sides of the limiter to keep the system from traveling. Once the satellite is found, the next step is to find the direct center of the signal. To do this, we find the edges of where the satellite signal drops off on either side of the azimuth axis. Open up the azimuth fine-tuning nuts to create a small area of travel. Carefully watch the SuperBuddy for when the signal drops off on each side and move the azimuth nuts to the 2 locations. Once both positions are found, position the dish to the center of play and then finger tighten the nuts to lock them in. Finding the elevation center is done in a similar fashion. Find the signal edges and then place elevation between the 2. With both azimuth and elevation centers found, the dish is fairly well aligned. The signal reading on the SuperBuddy should reflect the highest reading as well. To peak the skew axis, the right meter reading is used. Simply rotate the skew for the highest possible reading.